Hello everybody, we are on day 12 of our paleontological dig at Court Farm. My name is Sally and Spence and we have a few students here from 5 different universities. We've also got lots of different experts coming in throughout the 2 weeks as well. And one of those is behind me. This is Dr. Philip Copestake and he is a geologist. So we're going to meet him. Hello Philip.
Hi.
Philip, you've been getting really excited about all the stuff here.
Absolutely.
Can you explain what we're looking at from a geological point of view then?
Right, so obviously the reason everyone's here is because of the fantastic fish and other fossils that have been found in these nodules here, which you can see here, which have been numbered. And we've got some people here currently splitting them, looking for the amazing fossils that are in this level. But on a broader picture, this site is really important because of this level. This level represents a global event. Mm-hmm. It's called the Toarcian Ocean Anoxic event. It took place around about 183 million years ago.
Can you explain to us what that event actually means?
Yes, so it's an interesting event. It's thought to be a warming event, mm-hmm. and it caused a bloom of algae in the water mass, and that's associated with anoxia, which means a complete absence of oxygen.
So that's
at the seabed.
That's not good for sea life.
No, it's not good for sea life, but it's good for preservation, because normally when organisms die and they sink to the seabed, they get predated, they get destroyed. So, a lot of them are not preserved as fossils. But what's happened here is because this level is anoxic, and you can see it in the lamination here. This is the shale.
We'll show you this.
It's formed of these layers. It's very laminated. You can see it. These are organic rich layers, and these are telling you how organic rich this is, and the nodules are in this layer. You can see over here. The nodules are sitting in this laminated layer, and also there's lamination above the nodules, so the nodules are in this layer.
Right.
And because this is anoxic at the seabed, it's preserving the fossils, because there's no bacteria there to eat the fossils and destroy them. So that's why they're preserved.
Okay, got you.
But on a bigger picture, this level, this ocean anoxic level, is one of several that occur in the geological record. There are a number of them that occur throughout geological time. And this one, it's called the Toarcian Ocean Anoxic event, TOAE. And this is a near global event. It's been found in many parts of the world, always at the same level, often associated with fantastically preserved fossils. Mm-hmm. It's thought to have been a major climatic event. There are lots of ideas as to what caused it, but one of the most recent ideas is it's due to a massive volcanic eruption that took place in South Africa at the time. And that caused a huge outpouring of CO2 into the atmosphere and warming. And the warming then caused the bloom of algae, which is what this represents.
Got you. Okay. And that as you say, that bonds it all together, really, why we're finding the fossils we're finding them. Right. But also, you found in another trench that we've dug.
That's right.
You found some very different fossils than what we've been seeing in this trench.
That's right. So we have dug sections above this level to get an idea of the sort of broader stratigraphy, if you like, of this site. And these are just some examples of some of the fossils that we found in the younger section. So this is a really interesting nodule level that we've discovered up there, and you can see the concentration of fossils in here. Really important to us as stratigraphers are ammonites like this, because these help to date the rocks.
I was going to say, you specialise in microfossils, don't you? So
correct.
Tiny fossils.
That's right. So I'm here as a micropaleontologist. So what we're going to do is sample all of this section, look at all the microfossils throughout the section, both below the nodules and above, to try and help date this section and put it in a geological timescale. We think we know what it is. We think it's this Toarcian anoxic level, but we want to absolutely confirm that.
Confirm it.
And the other thing that the microfossils can do is they can help understand the paleo environment of deposition at the time, like what I was talking about with all the organic richness. If we sample this, we should be able to actually get access to all those organic rich microfossils that are occurring here and identify them and prove that that's what this is.
So when we talk about microfossil, can you describe some of those microfossils to us?
So the main groups that we're looking for three groups really. We're looking for foraminifera,
Yeah.
which are effectively amoeba with shells.
Mm-hmm.
So you see amoeba in the present day, but they don't have shells. But in the geological record, they become preserved as fossils. The shells become preserved. And they can help you date the section. So we've got a zonation scheme based on the foraminifera. That's something that I've done in my research past.
This is why we have the trenches stepped.
Yeah, indeed.
Yeah.
And then ostracods are also another important microfossil. These are little crustaceans. They're a little bit like fossilised baked beans, tiny little things. But you can only see them down a microscope. They're not visible to the naked eye.
So how will you preserve, how will you remove them from the rock then?
Well, what we're doing is currently sampling. So we'll take samples, really focusing in on the clay levels. We would struggle to get microfossils out of these. But from the actual clay levels, we will wash them through a sieve, wash them with peroxide to break down the clays. And then just wash the clays away, and you just left them with the microfossils and look at them down the microscope, identify them.
So this is what we were
So that's the
saying
process.
earlier, that there is so much work that goes on with this dig behind scenes. After dig's finished, it just continues, doesn't it? It's just a phenomenal amount of research attached to it.
That's right. So once we've collected the samples today, we'll put them through the lab, and then we'll pick them, look down the microscope, pick the bugs out, identify them. So there's a lot of work that's going to take place following today.
And there were some crinoids in here, which I don't know if I can see any in these particular samples.
Yes, here we are.
Oh, here we are. There we go.
Yeah, so these nodules are not from this trench. They're from a younger trench. So you can see these little pink fossils in here. These are crinoids. They've broken up. The original crinoid looks like a little bit like a plant. It's got branches and so on, but when they die, they become disarticulated, so you're just left with lots of little ossicles, and that's what you have here.
Well, we went out with UV torches the other night and put the UV torches across these particular nodules, and they just glowed a universe full of crinoid stars and all sorts of different things. Wow. Absolutely stunning.
But it's the ammonites that are occurring in here, as you can see some of them here, which are really important for dating the section. Having said that, I can't see any in this particular lump. But,
I think there was one. There was definitely one. I did see. Well, there's a bit of an ammonite there.
Yeah.
And you've got a better one there as well.
Yeah, there's quite a good one there. So although they're not as fantastically well preserved, these are still really important because they help date this rock.
And that's, again, a very different nodule to this one that's absolutely full of fish scales.
That's right. So that's a nodule from this level, and these are fish fragments.
So it's all telling us a picture, basically, of the environment of that period of time, what was going on in the oceans, and presumably that enables us to learn a little bit about what's going on in land conditions in that case, the atmosphere.
Not so much. I mean, most of the environment at this time in Britain was submarine. Mm-hmm. So this is a deposit of a shallow sea that was present over most of Britain at the time. So,
well, it is absolutely fascinating. So we're still learning more, and we've got an awful lot more to learn yet, because as I said, Philip points out, a lot of this work will continue long after the dig has finished, which is only in a very short time now. So do look back at our videos. We dig fossils on our YouTube channel, and also our hashtag, which is fossil fishing. And thank you very much for explaining that to us as well, Philip.
You're welcome.
Thank you.